6.1 Angle measure. Angles consist of two rays with a common vertex. We interpret an angle as a rotation of ray 1 onto ray 2. So basically we take one and we're kind of spinning it around, rotating it until it becomes the other ray. Ray 1 is what we consider the initial side, and ray 2 is the terminal side, and that's really what we're going to call them from here on out. The initial meaning the starting side, terminal meaning like to terminate or ending side. If our rotation is counterclockwise, so if we start by going up, we consider that angle to be positive. If instead our rotation is clockwise, we're going down first, that means that our angle is going to be negative. Now we're going to put these angles onto our unit circle, and that's where you're going to probably see it a little easier, where it starts to get positive or negative. The measure of an angle is the amount of rotation about the vertex required to move from ray 1 to ray 2. So kind of that gap, how much we have to fan it out to get to the terminal side. We have actually two ways of measuring angles. Now in geometry, you would have discussed degrees, and we know that an entire circle or a full angle is going to have 360 degrees in it. So 1 degree is 1/360th of a complete circle or a complete revolution. That's what we call going around the circle an entire time. Radian, on the other hand, which is a new measurement. Think of it as saying feet versus meters, right? Or yards versus meters. It's just a different measurement. Radian. So radian's the other one, and 1 radian is actually a little more than 1/6 of the way there. So there's a little more than 6 radians in an entire circle. So where radian comes from has to do with, well, it kind of looks just like the word radius, right? It has to do with our radius. So if a circle has a radius of 1 and its vertex is at the center, then the measure of an angle in radians is going to be the length of the arc that subtends the angle. So it's that arc length from, if you think back to geometry, that's going to be real important here. So the circumference of a circle of a radius 1, right? We remember circumference of a circle is 2 pi r. So that's going to be 2 pi times 1, so 2 pi. So if we have a radius equal to 1, our circumference is going to be 2 pi, okay? So a complete revolution is going to be 2 pi. That's the arc length. That's also the radian measure. So an entire circle is 2 pi, which means half of a circle or a straight angle, which would have been 180 degrees, is going to be half of that. Well, half of 2 pi is pi. And then we could even start to think, well, what's half of pi? And that's pi over 2. And that's where our numbers from our unit circle came from. And it doesn't have to have pi in it to be radian. Remember, pi really just means about 3.14. Pi over 2 really just means half of that. So 3.14 divided by 2, it's about 1.57, and so on. So if you notice, pi over 2 is smaller than 2, right? 1.57 is smaller than 2. We can convert back and forth between degrees and radian, just like you can convert, between miles and kilometers, or whatever your measurement is from different systems. So in order to bounce back and forth, what we think about is that half circle. So halfway around the circle is 180 degrees, right? A semicircle is 180. Well, halfway around a circle in radian is pi, because the whole thing's 2 pi. So we can kind of use that to fix our situation here. So if we're starting in degrees and we want it to equal radian, we're going to multiply by really radian over degrees to cancel it. So pi over 180, and that will give us radian. If I start in radian and I want to convert to degrees, I'm going to do 180 over pi as my, really kind of my scale factor here. Okay. All right, so let's convert between radian and degrees. So here I'm going to give you 60 degrees. We want radian as our answer. So in order to go from degrees to radian, we're going to multiply by pi over 180 degrees. All right, when we multiply that, we're going to leave it in terms of pi. So that would be 1 pi over 3. And that's radian. Now, if we don't put a unit on the end, we assume it is radian. But it doesn't hurt if you want to put, the shortened version would be rad. If you do want to put it, you don't need to write the units for radian. You do need to write them for degrees. All right, and then pi over 6 times, all right, well, that's radian. We want to turn it into degrees. So we're going to do 180 on top, degrees over pi. And then what will happen here is those pi's will actually cancel. So really we have 180 over 6, which is going to give us 30 degrees, which should look familiar from our unit circle. All right, so angles in standard position. An angle is considered to be in standard position as long as its initial side is on the positive x-axis. And actually, I don't even love this drawing. In my opinion, I think it is best to actually draw that initial side in, but you can tell where the initial side is without drawing it if you notice where this arrow starts. Right, if you find the end of that, not the pointy side, not the actual arrow part, but the end point of it, of that kind of curved ray there, you can see that it is starting on that positive x-axis. So those are all considered to be in standard position. Now, recall, these are the numbers that we had from our unit circle, and they're so very important for helping us to kind of guess where things are without having to do a lot of work. So if we can figure out about how many degrees, say we wanted to graph 75 degrees. Well, it's not on here, but if I know where 60 is and I know where 90 is, it's going to make my life a lot easier. Oops. All right. So two angles in standard position are considered to be coterminal if their sides, the initial and the terminal sides, coincide, meaning they are in the same spots. So I could have something like this. Here is my my initial, maybe here is my terminal. This green angle would be coterminal with this yellow angle because they're starting and ending in the same place, even though they're doing a little bit extra. Now, what's even more important is not so much those where we're going kind of around the circle a lot, but would be the negative counterpart. And we'll see that kind of a little later on in these chapters. All right, so let's find the angles that are coterminal with 30 degrees. So here's how we can find coterminal. We can add or subtract a full circle. That's really the solution here. If you add or subtract a circle, so either that would be 360 degrees or 2 pi, depending on what measurement you're in, that's going to give us our coterminal angles. So if I have 30 degrees, if I add 2 pi to, if I add 360 to that, that's going to give us 390. That's going to be coterminal. If I take 30 degrees and I add 2 circles to it, that's going to give us 720 is what we're adding. So 750. That also would be coterminal. We could even go the other direction. We could say 30 degrees minus 360. Take away a circle. That would give us negative 330, also coterminal. And I can just keep doing it however many times I want. There are infinitely many coterminal angles. So generally, when we're looking for them, we'll give you some restrictions. Find the coterminal angle between, I don't know, 0 and 500 or something. You know, we might restrict it so that we're not getting tons of different answers. All right, so find angles that are coterminal to now this radian angle. So we have pi over 3. So same concept. We can add 2 pi to that. Just don't forget we want to make sure we're using a common denominator here if you're doing it by hand. So that's going to be over 3. So 6 pi over 3. So when I add, that's actually going to give me 7 pi over 3. And we do not want decimals here. We do want exact measurements. So that's coterminal. I could subtract. I could add it a few different times. Oops, I said subtract. So that would give us pi over 3 minus 6 pi over 3. So that would be negative 5 pi over 3. We could add 2 pi several times. We could subtract 2 pi several times. They would all give us coterminal angles. All right, we want to find an angle with the measure between 0 and 360 that is coterminal with the angle of 1290. All right, well, I want my answer to be in between 0 and 360, so adding is only going to make this number worse. We want to start going down. So we'll take 1290 and let's subtract a circle from it. All right, so let's see, 1290 minus 360, that's going to give us 930. Okay, still not within our restriction, so why don't we subtract another 360 from that? So that's like subtracting 2 circles from the original number. That's going to give us 570. It's better, but not quite there. I think if we do it maybe one more time, so minus 360, we'll take away a third circle. That is 210. Perfect. That's between 0 and 360. So really what I did here was say 1290 minus 1, 2, 3 times 360. Okay, so we can continue to add or subtract a full circle to continually get our infinitely many terminal angles. Coterminal angles.